Okay, in the first video we looked at questions 1 to 11. Let's get started on question 12. ABCD is a parallelogram. E is the point where the diagonals meet. Prove that the triangle ABE is congruent to triangle CDE. So, congruent, different to similar. If two triangles are similar, it means they have the same angles. If it's congruent, it needs to have the same size as well, so any congruent shapes are exactly the same. We need to show that triangle ABE is congruent to triangle CDE. We need to show that those two triangles are exactly the same. So we're going to do that by showing that the angles are the same and the lengths. There are lots of pairs of angles that we can show are the same. One of them is angles BAC and ACD. Because these are parallelograms, those lines are parallel, so what we've got here is the alternate angle. Alternate angle with all this Z angle going on there. So we can show in our working first that angle BAC is equal to angle ACD. And that's because they are alternate angles. Next, we could show that angles ABD and BDC in the exact same way are alternate angles, but let's have a look at a different one. What we're going to look at here is AEB and DEC. Those are the same because they're opposite angles. So we would write down angles AEB is equal to angle DEC. And that's because they're opposite. So far we've proved they're similar triangles. We've shown that their angles are the same. We now need to show that they're congruent, so we need to show they're the same size. To have the same size, we need to show that they share a side of the same length. That's nice and easy to show because it's a parallelogram. Opposite sides are going to be the same. So to show that, we just need to say AB is equal to DC. That's just because it's a parallelogram. So far we've given enough information to show that they are congruent triangles. We haven't actually shown that we know that they're congruent. If we have two angles the same with a side in the middle the same, they must be congruent. So we'll just say that angle side angle are the same, so congruent. There we go. Question 13. Mr. Brown gives his class a test. 10 girls in a class get a mean mark of 70. 15 boys in a class, they get a mean mark of 80%. Now Nick, he says that because the mean of 70 and 80 is 75, then the mean mark of the whole class is 75%. Nick has made an epic fail. Is the correct mean mark less than or greater than 75%? Question's only worth 2 marks, so you just need to give a little bit of writing. First, you've got to show that there are more boys than girls. That's going to skew the mean mark closer to the boys. So I would just say something like more boys than girls. So that makes the mean mark is going to be more than 75%. Alright, question 14. Show that 4 minus root 3 times by 4 plus root 3 divided by root 13 simplifies to root 13. This question's only worth 2 marks, which I think is a little harsh. In a real exam I'd expect you to get 3 for this, hopefully. You do have to show a fair bit of knowledge. You need to be able to expand brackets and work with surds, and you have to do it all accurately. So I would expect 3 marks. But let's show you how the marks can give you the 2 marks. First, you expect to be able to expand out the double brackets using surds. So we've got 4 times 4, that's 16. We've got minus root 3 times plus root 3. Minus times a plus makes a minus. And root 3 times root 3 is just going to give you 3. We've got 4 times plus root 3. That gives you 4 lots of root 3. And we've got minus root 3 times 4. So we've got 4 lots of minus root 3, giving you minus 4 root 3. Now the plus root 3, the plus 4 root 3 and the minus 4 root 3, those are going to cancel out. So we've just got 16 minus 3 on the top, 13 divided by root 13. Now we need to show that simplifies just down to root 13, so we're going to have to what we call rationalize the denominator. We've got a surd on the bottom, an irrational number. We need to rationalize the bottom part of the fraction, make it a rational number. So we start off with 13 over root 13. And the trick here is to multiply that by root 13 over root 13. Multiply fractions together, we multiply the numerators. 13 times root 13 will give you 13 lots of root 13. And root 13 times root 13, that's just going to give us 13. The 13s are going to cancel, giving us just root 13. Okay, question 15. Bit of indice work. Make sure you know your indice rules. Starting off with A. Find the value of the cube root of 8 times 10 to the 6. So we've got the cube root of 8 times 10 to the 6. Now we know if we're doing surds, we're doing square roots, we can split these up into individual ones. So this is just the same as the cubed root of 8 multiplied by the cubed root of 10 to the 6. Now, cubed root of 8, that's just 2. 2 times 2 times 2 is 8. Cube root of 10 to the 6 is a bit trickier. It might be easy to think of this as a cubed root as an indice. So this is the same as 10 to the 6. Cube root we can write as a third. When we're doing the power of a power, we just multiply the powers. So that's the same as 2 times 6 times a third. That's 10 to the power of 2. And 2 times 10 to the power of 2 is 200. Just the one mark there. So a couple of 2 markers. Find the value of 144 to the power of a half times by 64 to the power of minus a third. So this just means the power of a half is square root, so that's going to be the square root of 144 multiplied by, now the minus a third, power of a minus, the minus means it's going to be 1 over, and we're going to get 64 to a third. So we're going to end up with the cubed root of 64. The square root of 144, that's a times table we know, that's 12 times 12. And we're timesing that by 1 over the cube root of 64. You might know that. If you don't, just try a few numbers. 5 times 5 times 5 is 125, so that's too many. 3 times 3 times 3 is 27, that's too low. So 4 times 4 times 4 is 64. And 12 times a quarter, 3. So part C is a little trickier. We've got 3 to the power of 2x, and that equals 1 over 81. When you're working with indices and you want to find out what the indice is, in this case the 2x, we need to know what that is. The way to do that is try and write the other side as 3 to the power of something. And once you find that something, you can compare the two. So we're going to write 1 over 81. Our aim is to try and write this as 3 to the power of something. Well, 1 over 81, that's 9 times 9. 9 times 9, well, 9 is 3 times 3. So this is going to be 1 over 3 times 3 times 3 times 3. So it's 1 over 3 to the power of 4. And we just want this as 3 to the power of something, and as it's reciprocal, it's going to be 3 to the minus 4. This means that 3 to the 2x must be the same as 3 to the minus 4. So 2x and minus 4 must be the same. So we can just write down 2x equals minus 4. Or just realise that must mean x is minus 2. Okay, question 16. We have probability that Sinai is late for school as 0.05 and the probability that Jaden is late at 0.15. So what we can take this to mean is that 5% of the time Sinai is late and 15% of the time Jaden is late. Alfie says the probability that Sinai and Jaden will both be late for school is 0.0075 because 0.05 times 0.15 is 0.075. Which is true, the maths is fine, but is that the right way of going about it? What assumption has Alfie made? Well, the problem here is we don't know if Jaden and Sinai have an effect on each other being late. They might not know each other at all, and these are just their percentages. Or perhaps Jaden and Sinai are friends. Jaden's a bad influence on Sinai. He's often late, and he tries to convince Sinai to be late with him as well. Maybe they go to a shop for some sweets or something. So maybe the 5% of the time that Sinai's late, Jaden's late as well. They're always late together, but Jaden's just late more often. So we don't know if these probabilities have an effect on each other. Now, Alfie would be correct if we treated these as independent. If they had no influence on each other, like flipping a coin, one result doesn't affect the probability of the next. And that's when we can multiply the probabilities together. So for this to be the case, Alfie has assumed that the events are independent. Okay, question 17. Just a nice straightforward solve the quadratic equation. And they give us the form to write it in. We want to make sure we've left it as two numbers. One's a surd. There are a couple of ways to do this. If your answer is going to be a surd, you're not going to be able to factorize it. It's going to be a bit of a mess. So, two ways of doing it. You could use the quadratic formula, or you can complete the square. I'll show you both. First, I'll just go through the quadratic formula really quickly. So, as you know, and you must remember for the exam, our quadratic formula is b plus or minus the square root of b squared minus 4ac all divided by 2a. So, using our equation, we've got x squared, so a is 1. We've got minus 6x, so b is minus 6, and minus 8, so c is minus 8. So, into the quadratic formula, we get minus b. B is minus 6, that's just going to be plus 6. The square root, b squared minus 6 times minus 6 is 36, minus 4 times ac, so 4 times 1 times minus 8. That's all over 2a, so that's all divided by 2. That's just 6 plus or minus square root minus 4 times 1 times minus 8. 4 times minus 8 would give me minus 32, so minus 32 plus 32. All divided by 2, and that gives me 6 plus or minus the square root of 68 divided by 2. Now the answer wants this in the form a plus or minus root b, so I can't have a fraction on the bottom. I'm going to have to be able to divide 6 by 2, that's easy, that's going to be 3, but dividing root 68 by 2 is a little harder. What I really want is to write this as 6 plus or minus some surd with a 2 in the front. Now to have a 2, that's the same as root 4. So I need to split my 68 up into root 4 and root something else. Well, dividing 68 by 4, or halving it twice, 4 and 17. So that's going to be 4, 17. So the root 4 will turn into root 2, so this will just give me 6 plus or minus 2 root 17 all over 2. And if we divide both those by 2, we end up with 3 plus or minus square root of 17. Okay, so the other way of doing it is completing the square. It's a little quicker and it's worth knowing how to do because they might have said in the question by completing the square. And the aim when completing the square is instead of factorising it into two brackets, we're going to try and factorise it into a single bracket squared. Now we're not always going to be able to do this, we're going to have to add on something in the end, so let's have a look. X squared minus 6x minus 8 equals 0. If we could write this as a square, it would have to be x minus 3 inside the bracket, because when you expand this out, x times x will give me x squared. You'll get two lots of x times minus 3, so you'll get your minus 6x like that. But what you'll also get is a minus 3 times a minus 3, giving you a plus 9. So to make the equations the same, rather than having a plus 9 in it, we take that away, and we take away the 8 instead. So we get our minus 8, and that equals 0. Squared minus 17 equals 0. Okay, now we start moving everything to the other side to get x equals to find the solution. So equals 17, add 17 to both sides, square root, x minus 3 equals the square root of 17. You must remember when you square root something, it's plus or minus. And moving the 3 across, adding 3 to both sides, we get our answer, plus or minus root 17. Okay, question 18. Got a lot going on in this question. We have a right-angled triangle split up into 3 triangles. We've got some parallel lines in the center, and we can see that 2 of those lines are parallel. It tells us the area of triangle PNQ is 8 centimeters, and the area of triangle LPQ is 16. We need to try and find out the area of LMQ, that one there. So let's go have a look. Squared, and this one was 16 centimeters squared. So what does that tell us? Well, they both share this side in the middle. So if one has managed to double the area, that means that, so what we can say is that the line PL must be equal to double NP. That's the first step. Okay, so from there we can find out the area of the whole thing. Because if we know that the triangle NPQ has an area of 8, because these are parallel lines, it means that triangle NPQ and NLM are similar triangles. They have the same angles, just one's an enlargement of the other. P is double what NP is, then this to this must be a multiple of 3, because we've gone from, say, a side 1 to a side of 3. So then to get the area of LMN, you have to go 8 times by the scale factor of 3. Because 3 is for lengths, if we want the scale factor of the area, we're going to have to square it. So we've got 8 times 9 equals 72. So we found the area of LMN is 72. We're only interested in LMQ. So our area of LMQ, or LQM as the question says, is going to be the area of the whole triangle, all the ones they give us. Take away 8 and take away 16, giving us 48 centimeters squared. But you get them up for just 48. Question 19. A histogram shows information about the time taken for cyclists to finish a race. If 7 took 80 minutes or less to finish the race, so we've got 7 in there, work out an estimate for the number of cyclists who took more than 105 minutes to finish. So the important thing to know about histograms is that area represents frequency. So for this question, the area of this rectangle has to be 7. We can see here that we've got a width of 10. So what's the height going to have to be? Well, if we have 7 divided by 10, we get 0.7. So that means the height of that is going to be 0.7. It's what we call the frequency density. Looking at that, we need to find out how many people are in this area. How many people in between there and there, from 105 to 120. That's got a width of 15. And looking at the scale, if the height of this is 0.7, that's 7 little squares. So the height here, which is 12 little squares, will give us 1.2. So the number of cyclists took more than 105 minutes will be the area, which is 15 times by 1.2. That gives you 18. To explain why your answer in part I is only an estimate, it's group data. We have no idea if it's evenly spread or not. So group data, no idea how many cyclists between 105 and 120. Something like that. Okay, question 20. Some pretty hardcore algebra going on in here. We have to show that all of that simplifies to ax, where a is an integer, so we just simplify to some multiple of x. If you're simplifying algebraic fractions, what you want to do is you want to factorize everything, and you can expect some of those brackets to just cancel out. We'll have some of the same on the top and on the bottom. So let's have a look. Firstly, we have 3x plus 6. That can be factorized by taking 3 out as a factor. So we'll take 3, and we'll get x plus 2. On the bottom, we've got x squared minus 3x minus 10. So as a quadratic, we can factorize that into 2 brackets, x in both. So a number that multiplies to make minus 10 and adds to make minus 3, we're going to get minus 5 and plus 2. That's divided by x plus 5, can't factorize that, divided by x cubed minus 25x. Well, both of those terms have an x in, so we can take x out. That gives us an x squared minus 25. But we could have factorized this even further. X squared minus 25, we should be able to spot that as a difference of 2 squares. 3 brackets x plus 2 on the top, divided by x plus 2 times by x minus 5. And we're going to divide that by this fraction. When you divide by a fraction, that's the same as multiplying by its reciprocal. So that means we'll have 3x plus 2 multiplied by the bottom of this fraction, and x by an x plus 5, and an x minus 5. And on the bottom, just the top of this fraction, so that's going to be multiplied by x plus 5. Now we can see a lot of this is going to cancel down. We've got an x plus 2 on the bottom and 1 on the top, x minus 5 on the bottom and 1 on the top, and an x plus 5 and 1 on the top. So all that leaves us with 3 and the x. Alright, question 21. Solve the inequality x squared is greater than 3 times x plus 6. So it's an inequality, means we're basically just doing normal algebra but using inequality signs. we can see straight away we've got an x squared, and we can multiply this out, we'll get some x's and some constants. So what we're going to have is a quadratic equation. To solve quadratics, we need to make sure everything's on one side and leave a 0 on the other. So let's have a look. X squared is greater than, let's multiply this out first, 3x, and moving everything across, x squared minus 3x minus 18 is greater than 0. Now, to solve equations like this, particularly in a non-calculated paper, we're probably going to be able to just factorise, and yeah, we can. Two numbers at times to make minus 18, and add to make minus 3. 18 has factors 6 and 3, so if I make one a positive, one a negative, and x plus 3 greater than 0. So we found our two roots, x must equal 6 and minus 3. When you're solving inequalities, it's a little bit more complicated than that. We found the 2 points where it equals 0. We haven't found out where it's greater than 0. So let's have a little think about what the graph might look like. And we've got x squared minus 3x minus 18. It means we're going to get a positive smiley face. And it's going to cross at x's minus 3 and 6. Now the equation wants to know when is it greater than 0. Now the values are greater than 0 in the top half. So x squared minus 3x minus 18 is greater than 0 up here and up here. Is greater than 6, or x is less than minus 3. Okay, last question of the paper. Question 22. Definitely hard questions, particularly aimed at those of you that are looking for an 8 or a 9. So, let's get started. We have line L, which is a tangent to the circle, and they give us the equation of the circle. You need to make sure you know how they work. At point A. A is at 0.26. So let's have a draw of what this graph might look like. Let's make a nice big one. So first thing is we've got a circle. Now if the equation is x squared plus y squared, that means the centre of the circle is going to be right at the origin. So we get a circle at centre 0. Now we're looking at the tangent of this circle at 0.26. So let's have a look at this. Somewhere around here we'll get a tangent. So that's at 2,6. And tangent to the circle, just going to skim it, something like that. They want us to work out the area of the triangle O and P, where line L crosses the x-axis down here. So we're looking for this triangle here. Now because the line's a tangent, and we've basically just got the radius coming from the origin up to point A, that means that this angle there must be 90 degrees, and the width. Well, the height's easy, we can see that, because the A has coordinates 2, 6. The height across here is just going to be 6. The width is the harder part. We need to find out where this line crosses the x-axis at P. What's the x-coordinate of P? P, we're going to have to find the equation of the line L. So the equation of the line is going to be of the form, because it's a straight line, y equals mx plus c. That's our line L. Find the gradient m. Nice way to look is we know 2 points of this radius of the circle up in the top corner. The gradient is going to be minus the reciprocal of that because our line is going at 90 degrees. So first let's find the gradient of our radius that we've drawn in. The radius goes from 0, 0 to 2, 6 because gradients are the change in y over the change in x. The gradient of our radius goes, change in y, 0 goes all the way up to 6, so our change in y is 6, divided by the change in x, it goes from 0 to 2. So the gradient of our radius is just 3. That means that m is going to have a gradient of minus the reciprocal of that, minus a third. This y equals minus a third x plus c. Now to find out this constant, the c, we're going to sub in some values we know. Well, we know the line crosses at the point 2, 6. So we know it crosses that when y is 6 and x is 2. So minus the third. That's 2 plus c. Okay, so we've got minus the third times 2. That's minus 2 thirds. And we can just move that over to the other side. So that tells us that C is going to equal 6 plus 2/3. 6 and 2/3. Gives us the equation of our line. Y equals minus a third x plus 6 and 2/3. And where does that cross the x-axis? Well, it's going to cross the x-axis when y is 0. So, making y equal to 0, we get 0 equals minus a third x plus 6 and 2/3, meaning that a third x, if I move that over to the side, will equal 6 and 2/3. Multiplying everything by 3 will give us x equals, well, 3 6s are 18, 3 times 2/3 is 2, so that gives us 20. So across the x-axis when x is 20, well, we know that we had a height of 6, we now know we have a width of 20, so the area equals 6 times 20, base times height, divided by 2. 6 times 20, 120 divided by 2, and we're done. If you enjoyed that paper, you're going to love the calculator papers. Keep an eye out on this channel and they'll come out soon.